Hi everyone, our title would be the applications of enzymes used in the beverage industry. The contents highlighted would include the principle of what an enzyme is, and their uses in 4 different beverage industries, which include beer, juice, soda, and wine. So what is an enzyme? Enzymes are considered to be biocatalysts, meaning that they tend to increase the rate of a reaction by lowering its activation energy, and they do so by binding to a molecule termed substrate, hence giving rise to products. Looking into the beer industry, beer is considered to be a widely consumed alcoholic drink consisting of ingredients that include water, barley, and hops. The beer industry comprises many brewing steps involved in its production, and I will be delving into the various enzymes utilized in the main brewing steps categorized as decoction, mashing, fermentation, and conditioning. The enzymes used in decoction are alpha amylase and beta glucanase, which are used for the hydrolysis of starch and glucans respectively, amplifying the malt in beer. Next step involves mashing, that essentially serves the purpose of mixing proper proportions of grains, increasing availability of starch for effective enzyme action, collectively converting the starches into fermentable sugars. The fermentation process consists of yeast, which serves to metabolize the sugars extracted from grains to produce alcohol and CO2, thereby converting the wort from the mashing step into beer. Lastly, conditioning involves how a beer is carbonated drastically, affecting its final outcome, with the carbonation allowing beer to develop new tastes as it ages. So enzymes can constitute importance in the beer industry for many reasons as displayed, with the main role of enhancing and speeding up the reactions involved in beer processing.
So why are enzymes important in the juice industry? Well, having a high yield is one of the most important goals that the juice manufacturing industry pursues. As such, modern processes in the industry aims to employ enzymes as a means to obtain higher yields with higher clarity. However, fruit juices contain colloids that can lead to issues with the filtration process. One of such is the negatively charged colloid pectin. Pectin is a gel-forming agent present in fruit juices. Its fiber-like structures impedes the juice clarification process, significantly reducing the juice yield. To tackle this issue, acidic peptic enzymes such as pectinases are used to hydrolyze these pectins. Commercially, pectinases usually are made from a mixture of enzymes. They include pectinase, polygalacturonase, pectin esterase, pectin lyase, cellulase, protease, and amylase. This combination of enzymes causes the clumping of suspended components, which eventually form flocks and settles out. This reduces the turbidity and the viscosity of the juice.
Coke sells 1.9 billion servings of soda a day. This, alongside all the other sodas, mean that soda is probably one of the biggest drinks in the world. Coke and other sodas made in the US use high fructose corn syrup as their sweetener. High fructose corn syrup is made from cornstarch that has been processed by enzymes. First, alpha amylase breaks down the corn starches and turns that. Glucoamylase then turns all of the oligosaccharides into glucose. Finally, we have xylose isomerase, which turns half of the glucose that was produced from the last step into fructose, and this fructose is what we use to make the syrup.
For this session, we are looking into how commercial enzymes help in the production of wine. The biological process of winemaking is a result of a series of biochemical transformations caused by the action of several enzymes. The process of winemaking starts with pressing and maceration, which includes cellulases, hemicellulases, pectinases, and glucose oxidase. Fermentation is the second step, consisting of glycosidases. Clarification is the third step, which includes pectinases. Stabilization and aging is the last step, consisting of lysozyme proteases and ureases. In maceration and pressing, cellulases, hemicellulases, and pectinases are used to allow a better skin maceration and superior color extraction. It improves clarification, filtration, and the overall quality and stability of the wine. Glucose oxidase is used to reduce alcohol potential by converting glucose to gluconic acid. In fermentation, glycosidases are used for improvement of aroma by splitting sugar residues from odorless precursors that are resistant to ethanol and low pH. In clarification, pectinases break down pectins, which prevents pectin hazes, gives improved yield of juice, produces faster settling of juice, and increases the extraction of color components. In the last process of stabilizing and aging, lysozyme is used to control the growth of gram-positive spoilage bacteria, stabilize wines after alcoholic fermentation. Proteases are used for wine stabilization by prevention of protein haze. Urases are used for hydrolysis of yeast-derived urea, preventing formation of ethyl carbamate. In conclusion, we can see how beverage industries use enzymes to produce greater yield of better tasting beverage in a shorter period of time. This brings us to the end of today's video. Thank you so much for watching.
Created using Powtoon.